It is 12 o'clock, or better 12:01. So welcome everybody to a new edition of our Maritime Innovation Updates, MIU. I'm Etta Weiner and Public Relations Officer at the Fraunhofer CML. Today I have the pleasure of hosting my colleague's presentation with the title Autonomous Swarm Management System, WebUI at CML. Ching Nok-Au, also known as Andy, is going to introduce our software solution that is able to manage a large team of robotic systems, such as drones, submarines, ships, and crawlers. A few words about my colleague. Andy studied Information and Communication Systems at the Technical University of Hamburg and graduated as a master student in 2020. He joined the CML already in 2018 and has been focusing on building software and websites for robotic-related projects such as RoboVAS and Rapid. His research focuses on robotic as a service, and he would like to implement a safe, scalable, and easy-to-use platform for users to collaborate and operate on maritime robotic systems. As always, you can ask questions in the chat afterwards, which we will be happy to answer. Due to higher level settings of your or our organization, the chat may not be open to all participants. In this case, we ask for a show of hands and a verbal contribution after the presentation. Of course, you can also use the contact details of our speaker, which are shown at the end of the presentation. Please notice the presentation will be recorded and are published on our homepage. Therefore, please leave the microphones and cameras switched off. Thank you very much. And now, please enjoy the presentation of my colleague. Andy, the stage is yours.
Thanks a lot, Etta, for the nice introduction. So, hello everyone. I'm Andy from Fraunhofer CML in Hamburg. So today I will talk a bit about the management of autonomous multi-drone operations for maritime scenarios. Here are the topics we'll go through. Firstly, I will recap on the use cases related to robotic services. Secondly, I will give some update on the current robotic fleet of CML. Thirdly, I will talk about the concept of UTM and how it can manage autonomous swarm missions. After that, we'll outline our approach on the implementation towards a simple UTM system. The mission cycle and the logic will also be briefly mentioned. Finally, I will provide a simulation setup to verify the safety features of a UTM in general. So in my previous MIU, I've already defined some terms related such as robotics, unmanned vehicles, and teleoperation. So we have discussed what is robotic as a service, as a business model, and why it is sustainable. And we listed several use cases and illustrated the anti-grounding surface in particular. And lastly, we introduced the WebUI and the benefits of using web technologies as a user's interface. So if you want to rewatch that video, the link is also here. So CML has an expanding list of maritime use cases that can be wrapped into separate robotic services. And the latest use case at the bottom are more related to maritime safety and security compared to the previous survey-oriented data collection use cases. These are more dynamic and hard to predict. So to cope with all these demanding use cases, CML's robotic fleet is constantly being upgraded and extended. Currently, we have several aerial drones, underwater vehicles, and crawlers We have also built several ships ourselves and special purpose payloads to fulfill special project needs. So our latest UXV Sea Dragon on the bottom left-hand side was completed earlier this year. It is fully electric, has a range of about 30 kilometers and can be extended with onboard batteries. And it can also carry a capacity of 350 kilograms. It can act as a carrier to move crawlers or other vehicles to perform missions remotely. On the Sea Dragon, we are testing payloads such as LiDAR sensors, 360 cameras, multi-beam underwater sonars, and also our in-house developed emission sensors called the MIU box. On the other hand, the battery hot swap system for UAVs was completed last year after a successful demo, and it enabled UXV to act as an aircraft carrier in general. And lastly, there are land-side payloads to collect data. They are equipped with antennas and cameras to observe and collect signals from nearby air traffic, sea traffic, RTK, and GNSS satellites. So in order to achieve autonomy, the data from these payloads are processed on board in real time to enhance the situational awareness of the fleet. The beacons and processed data or detected objects, bounding boxes, can then be compressed and streamed to our server. After a successful mission, depending on the onboard sensors, we can collect GNSS data, image, videos, LiDAR point clouds, gas concentration data, and so on. For the purpose of inspection, the resolution of the 3D mesh is better for a close range flyby, but the time to scan in high resolution will also be much longer. So in here, we can see the 3D mesh created by flying at around 100 meters above ground. It looks okay-ish from a distance, but it is not detailed enough to fulfill inspection purposes. So if you want to do a high resolution scan, it takes a long time, which affects the infrastructure uptime. So we want to do it faster and more efficiently. So theoretically, of course, you can achieve better coverage and higher speed with more drones working in parallel and possibly autonomously. On the other hand, the UXV can also move a UAV around to targets which is far away. And such kind of collaboration combines the agility of aerial drones and also the stamina of the UXVs. Achieving this, of course, comes with a cost. So more drones means it is easier to crash. Operators need to communicate more carefully with each other, and everyone have to make sure the tasks are all well synchronized. Especially in the urban area, circumstances are less predictable, such as an uninvolved person might appear out of nowhere, and these risks need to be addressed and reported to the insurance company when needed. Therefore, some sort of traffic management system need to coordinate this kind of efforts in some way. And this is where the UTM concept comes in. So what is it about? So UTM refers to the unmanned traffic management system. It refers to a set of services for managing unmanned vehicle operations. It should be interoperable with also external systems such as air traffic control or vessel traffic management systems. Since operations take place in built urban area often, the public stakeholders might also need to be addressed or informed. These services helps to enable the fleet to get important updates on the latest situation. So here are some recommended functionalities of a UTM. So I will not go through one by one, but there are 3 tiers. The basic services ensures all resources and user interactions can be identified and traced. The intermediate services help to establish a clear overview of any planned and ongoing operations. So it focuses on gathering live data and also historical data. Mechanisms should be in place to avoid resource conflict and who can do what and what not, etc. So with this achieved, the final advanced level is to make for the high-level manager to make well-informed decisions and possibly change the flow of the mission. So the advanced services will turn such decisions into actions. For example, whether we should interrupt a mission, if there are some nearby aircraft or oncoming ship traffic, how do we give way and when? And should we change the route dynamically due to a sudden bad weather, for example? These are all addressed by the advanced services. Now we are clear what is a UTM. I will move on to the implementation of a simple example using the WebUI. So first of all, we have several design goals. First of all, it should work over the internet using web-based protocols for the maximum accessibility for users. The data, secondly, should be real-time and also encrypted and secured. The interface should be also user-friendly, intuitive, and easy to set up. About the user, the UTM is supposed to interact with a wide range of different users. So far, we have identified at least 9 user types. In general, complex missions involving more different types of UXVs would involve more different user types. For instance, an operator can only manually control one drone at a time, but a supervisor role, he or she can handle multiple UXVs, but only in semi-autonomous mode. On the other hand, missions requiring risk assessment sometimes, they will involve an external approver to review the details before the mission can be occur. And finally, a controller should oversee the airspace and sea space, and he or she can interrupt an ongoing mission based on new events arising from the vicinity. Okay, now the user roles are sorted out. We have defined some mechanisms to prevent resource conflict. For example, the direct control link between the operator and vehicle must be one-to-one, and it is used only for manual flight or So supervisors can deploy waypoints to multiple drones, and vehicles can at most participate and check into a single mission at a time. And about the WebUI interface, here are some screenshots from the graphical interface. After login, users can navigate to pages to view the fleet status, the payload, the mission list. They can also interact with other operators or other users. They can check the live map status and etc. This interface is designed to fit on most devices. So it is convenient to open different pages on multiple devices, such as tablets or even mobile phones, to get a better overview. As we are pushing our progress in the intermediate level services, we integrated various data sources to enhance the geo-awareness and the situational awareness of the UTM. For instance, we use OpenStreetMap to query and locate infrastructures such as locks, quays, bridges. For the air traffic data, we use ADSB Hub to fetch live feed. from AIS Hub, we can get sea traffic data. And there are also other open source satellites data we can get. We can get imagery, we can get weather data, and also elevation data for mission planning. Further, we can refer the output from previous missions. For example, we can use the high resolution scans, and we can overlay this kind of information onto the map to give a higher resolution to end users for planning. Okay, now we have an implemented UTM, and we would like to test and verify whether it can detect safety risks or hazards. For that, we have to create a mission that outline our use case. And in this case, the inspection. So for the mission concept, a fleet of 2 UAVs plus a UXV is sent from the CML building to a lock which is around 2 kilometers away, and to scan the wall, scan the quay wall for crack development. One of the UAV is carried by the UXV to near the target. Then it will take off, scan one side of the lock, land on the UXV again. Meanwhile, another UAV will fly to the target independently, and it will scan the other side of the lock in parallel, land on the UXV afterwards, and complete a battery swap, and then it will fly back to the CML home point. The risk here are mainly sea traffic along the route and pedestrians nearby the target lock. Afterwards, we realize the mission concept using the mission planner. We create the geofence, points of interest, takeoff and landing points, the waypoints, and the mission task to be done by each vehicle. And finally, we can deploy the waypoint to the vehicles to carry out the mission. So instead of using a real hardware, of course, we simulate the behavior using the physics engine provided by the Gazebo library. We simplify the model first to keep a real-time factor of 1, so we don't need to adjust the time for the traffic data. So after the simulation starts, the surface layer will visualize the beacons from the vehicles. A live monitoring surface will keep track of all traffic and vehicles in the vicinity and determines if any of them are too close to each other. The results are then updated to users. So apart from collision risk, there could be other type of risk, including loss of connection, mechanical or controller failure, and so on. In future, we would also simulate these and use it to test how the surface, test how the UTM reacts and whether the human in the loop event can be triggered accordingly. And this is the end of my presentation. I wish you find it useful. Thank you for the attention.
Yes, thank you very much, Andy. I have a look at our chat room. As I don't see any questions and I don't see anyone who raises his hand or her hand, I have some questions for you. How does this technology concern an average person? So is this platform open for everyone?
Yes. So in any, as I mentioned, the system, sometimes the drones will fly in urban area or built area. Although the regulation is not quite there yet, so we are not allowed to fly there freely. But we expect people at the end should be informed about the live status of what's going on above their head. So this is for safety and also for privacy purpose.
Mm-hmm. Okay. And what about the competition in the area of UTM platforms?
There are a lot of different manufacturers of drones or parts. They have implemented something similar, but nevertheless, they're less concerning the whole mission flow. Rather, they just provide an interface for user to control the drone, fly it around, and gather data and save it in the database. But what we are aiming for here is a bit more ambitious. We're trying to provide a more generic platform with all kinds of use cases for maritime usage.
Okay, so that leads me to my last question. What is your develop plan for the next year, for 2025?
So currently, the platform can already stream data quite well, including some imagery videos, and we are currently working on streaming point cloud data. And for upcoming year, we would like to focus more on the refining the mission planning interface so that we can provide a more user-friendly experience for operators to operate on multiple vehicles at the same time, because that is the main point of the platform, is to increase efficiency and safety.
Yeah, great. Sounds good. Thank you very much. There's nobody else who wants to ask something. So once again, thank you for you, Andy, and thank you for the audience. And yes, see you next time, and have a nice weekend. Hey, yes, and here we go for our next time, the presentation of Hannah Pache. You can already go on our homepage and register for it if you wish, and we would be happy to see you in a week's time. Thank you. Bye.
Thanks. Bye.